your calculator is doing is that formula. That's all it's doing. It's summing up 1 over n factorial, where the first term is 0, 1, 2, and on, and summing them up. Okay, so the first thing we did was factoring out common factors. It is the key and foundation to all factoring. All. It is extremely important. Now, when I looked at your homework, some of you really don't know what you're doing yet. That's bad, because yesterday only one person really asked me a question about anything involving the last 6 or so problems where you had a factor. And yet some of you had 4 and 5 or so of those problems wrong. Now, if you leave it that way and you don't get the concept figured out, you are going to be in trouble not only this chapter, but pretty much most chapters the rest of your math career. Because from this point on, factoring becomes a normal routine in a good portion, 70% of what we do from here on out. So you got to get the concept down, and you got to make sure you understand what's going on. And the start of it all is factoring out common factors first. So that's the first thing. That's the first concept you've got to learn. And that was what you should have learned over the weekend. If for some reason you don't have it down, my advice is go back and watch the video. Seeing it now a second time, you might catch more and understand more of what's going on. We'll also review that concept constantly the rest of the way. But if you're in the dark, you got to get out of the dark. And the other way to do that is come by after school and spend a little bit of time with me, ask me some questions about it, and I'll show you one-on-one what we're doing and try to make it clear to you. But you got to get that down, you got to get that down, you got to get that down. Okay, enough of that. All right, so now we need to factor trinomials. And they're a little bit different animal. They're a little bit different. So a couple keys. When multiplying 2 binomials, and then take your blue here, the middle term of a trinomial is the sum. So you're going to, sum is addition. I'm going to put a plus sign above sum. Of the multiplication, I'm going to put a raised dot there. So you got to sum up multiplying the outer terms and the inner terms. You got to add the outer terms and the inner terms to get the middle term. Okay, so let me try to show you this with the polynomial I have listed. So if you look up at the screen, don't write this in your notes. I've already done the first part, right? We have a binomial times a binomial, right? And the first thing is we're going to distribute. We're going to take the x front times front, and we're going to get this x squared, yes? It's the first thing in distributing when multiplying a binomial times a binomial. Okay. The second thing you would do then, and this is in green, you're going to take that x and distribute it to the back number, correct? And get a positive 2x. Take your green, and right here in the middle, positive 2x. Right? We're just multiplying this thing out. The next thing you would do now is go to the back term in the front, right? The negative 5. So again, I already showed you the arrow here, but in red, we're going to multiply the negative 5 times x, right? Those are the inners. So negative 5x. All right, so take your green again, and let me be clear. The x in the front times the positive 2 in the back are the outers, right? The 2 outer terms. The x is on the outside in the front, and the 2 is on the outside in the back, yes? Those are the outer terms. Take your red, and above the arrow, write inners. Because the negative 5 is the inside term of the front, and the x is the inside term of the back. Those are the inners. Now here's the key of factoring, because remember, in factoring we are unmultiplying, right? We're going backwards. Please notice where this negative 3x came from. The negative 3x in the middle of the trinomial came from adding the outers plus the inners. This is the key to all factoring of trinomials. This is the key of all factoring of trinomials. This is the key of all factoring of trinomials. Is making sure that you choose correct values that put the correct middle term there. And where does that middle term come from? Multiplying the outers and adding to it the multiplication of the inners. And by the way, if we finish this out, I already did it, you don't need to do this in your notes, but you would finish out with the negative 5 times the positive 2 and get that negative 10, right? Again, for a final trinomial of x squared minus 3x minus 10. So look, in chapter, I don't know, 9, we multiply binomials. In chapter 10, we're going to unmultiply trinomials. We're going to factor it. So again, chapter 9, this becomes this. In chapter 10, this goes back to that. Factoring is a means to an end. Why do you factor? To be able to do something else. This is important, so I'm going to take a second and just make sure you understand. If you are working a problem and you come up with something like 6 over 15, you wouldn't leave the answer like that. You would divide out the common 3's and reduce that, right? You need it to factor to reduce. We're going to need the factor to reduce fractions. If we were multiplying two fractions, it'd be top times top, bottom times bottom. And what are you going to do? Before you multiply, you're going to reduce, right? You're going to R-bum, reduce. How do you think you're going to reduce? By factoring the tops, factoring the bottom, dividing out common factors. If the bottom's about a trinomial, polynomial, we got to factor that trinomial so we can divide out factors. If you're adding fractions, you add the numerators and put them over the what? To add fractions, you add the numerator and put them over the common denominator. That's got to be in your brain. How do you get a common denominator? You know, if you had 1/2 plus 1/6, you'd have to figure out, I got to multiply this by 3 over 3. Well, we didn't have to do 6 over 6 because a 6 is a 2 times 3. We're going to apply that to polynomials, and again, it involves factoring. So factoring, 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 factoring. It's a means to an end. So right now, we're really unmultiplying, which is kind of a goofy way to leave an answer. Again, for example, would you ever leave an answer 2 times 5? Well, no. You wouldn't leave it factored. You'd say the answer's 10. So it's goofy to leave the answer 2 times 5. But remember, factoring is a means to an end. It's so we can do other things. And right now, we got to make sure you can factor. So we're asking for your answer to be the factors to see if you can do it so we can do the other stuff later. Kind of understand what's going on? Factoring is a means to an end. It's a means to an end. It's a means to an end. It's unmultiplying so we can do other things. But right now, we just got to teach you how to unmultiply. All right, let's get into these trinomials. It's all about the outers and the inners. Please, 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 please ask questions as we go. Remember, factoring is, and in red, unmultiplying. If that's a word, I don't know. I'm using it anyhow. This is math. You can do that. Remember, factoring is unmultiplying. And the key is making sure that your choice results in the correct middle term. It's all about the middle, assuming the other parts you use are correct. It's all about the middle, assuming the other parts you use is correct. All right, there's a name to this method, and this method is called, students don't like the name of this method, it's called trial and error. You know what trial and error means? Keep trying till you get it right. Some of you don't want to do that. Some of you honestly don't want to try past once. This is what you want to write. Well, look, go ahead and write stuck, but you're not learning anything. You're not learning a thing, and when it comes to test and you write stuck in the answer blank, it's not going to help you. You got to figure it out. Trial and error, you got to keep trying until you figure out the right pair. Now, it's my job to try to teach you some things that will hopefully get it to where it won't take you very many tries. And really, when you get good, your tries are in your head, not necessarily on paper. And you'll figure it out in your head and then write the correct thing on your paper. That's where I'll try to get you to. So please, please, please pay attention. Please, please, please ask questions. And I'll try to get you to where you can do this. But look, here's another key. One more thing I got to tell you before we get really going. Look, you can't take your trinomial, show it to your friend and say, how do you factor this? And your friend say, oh, that's x plus 2 times x minus 3. Okay, great. You have the answer on your paper. You have no earthly idea how to do it, and you're not going to be able to do it on the quiz, and you're not going to be able to do it on... You can't do that. It's not going to help you. You have to figure it out. You just have to. So do what you need to do to get it figured out, and I'll help you if I can. I'll be around after school today if I can help you. All right. When factoring, here's how you start all factoring. Always look to, take your red and finish each of these words, factor out common factors first. That was our first lesson, wasn't it? Factor out common factors first. That's how you start your factoring, by factoring out common factors first. Now, I'm going to bring this up 50 times this chapter, maybe more. And yet, listen now, students are still going to forget to factor out common factors first. And here's the reason why. It took me 30 years to figure out why, but I know why now. Not every problem has common factors. So though you look every problem to factor out common factors, at least the smart students do, not every problem has common factors. And because everyone doesn't, after you do a few, you kind of even forget to look. And sure enough, when you forget to look, that's one where you should have factored out the common factors first. So why do students forget to factor out common factors first? Because not every problem has common factors. But when they're there, you got to get them out first. All right, let's do a couple problems. So that's the blank there. Every polynomial does not have them, but you must look. And this is why students forget. Every polynomial does not have them, but you must look. Okay, so this first one, we've got a running total of what to do. Every polynomial does not have them, but you must look. Thank you, Kirsten. No Kool-Aid for you. I usually don't do a two-word blank, so it caught me off guard. I wasn't even looking. I was drinking Kool-Aid, not even reading. All right, let me get this higher up so we can look through. All right, so here's our first trinomial, x squared minus 3x minus 10. We have to unmultiply this. How do you do it? First thing you do, look to factor out common factors. Does this problem have any common factors? Remember, common is common to every term, so all three terms. And the answer is no. There's no common numbers for all three terms. There's no common variables for all three terms. Agreed? Okay. So the next step is, and I'm doing it in black, you make two parentheses. So you come underneath and you make two parentheses. Don't make them little. We need to stick two binomials in there. All right, the front of your binomials have to be two things that multiply to the front term. So number 3, the front are factors of the front. Our front is x squared, right? So our front numbers have to be factors of x squared. You have two choices. You have x squared times 1 or x times x. You'll find that almost always it is x times x. Now, as we go further and further in our factoring, we'll get to the point where the front will have some other possibilities. But an x squared is going to be an x times x. And so you put that in the front. Red x in the front of the left, red x in the front of the right. Now we got to figure out the back. Now here's the thing with the back. The back numbers are going to be factors of the back number. What's the back number of our trinomial? It's negative 10, right? So our back numbers are going to be factors of negative 10. Let's go ahead and list the possibilities. For example, a negative 10, or I'm sorry, a negative 1 times 10, doesn't that equal negative 10? There's one set of possible factors, negative 10, negative 1 and 10. What's another set of possible factors? Andrew? All right, negative 2 times 5 is another set of possible factors. Are there any more? Give me another one, Kirsten. All right, a 2 times a negative 5. And there's one more, right, John? And then a 1 times a negative 10. So look, we have 4 possibilities. It depends on the back number how many possibilities there's going to be. The back number's not so big, there's not so many to worry about. Now, here's the key, and look at the asterisk. You must pick the correct factors that produce the middle term, the negative 3x in the middle. Remember, where does the middle term come from? The outers multiplied plus the inners multiplied. So, I need you to put your pens down for a minute because I need you to watch. I need to try to show you what I'm thinking. Okay? So I know I got a negative 10. I know I got 1 and 10, or negative 1 and 10, and 1 and negative 10, and negative 2 and 5, and 2 and negative 5. I know those are my possibilities. This is the way my brain works. I always first look at the outers. That's the way I always do it. So I'm thinking, I got a negative 3 in the middle. I'm thinking if I put a negative 10 here, I already have a negative 10x. I have to therefore then put the 1 there, and that's a positive 1x, and that's not going to get me the negative 3x in the middle, is it? So really, literally what I usually think is once I have, this is really as far as my thinking usually goes on this. Once I do this and think negative 10 right there, I already say, you know what, that's not going to work. Because the other one's going to be a 1, and that's not going to get me to negative 3, and that's out. That trial is over. Didn't work. That's the way I'm thinking. So I think, well, what if I put the 5 back here? Now I'm thinking I got a 5x. The other number is a 2. Can a 5 and a 2 add up to a 3? Yeah, if one of them's positive and one of them's negative, right? And that's what it's got to be, because it's a negative 10 total. And now I'm looking, I'm saying, whoa, negative 3x. The 3 in the middle are negatives. Therefore, I better have more negatives than positives, right? So I better make it negative 5 on the outers for a negative 5x. And therefore, the positive 2 on the inners for the positive 2x gives me that negative 3x in the middle. And therefore, that's the correct factoring. All right, so now you can go ahead and write that. But that's the thinking of it. That's the thinking of it. This, I just want to show you what some of you will do. Some of you will have a positive 5 and a negative 2. You won't bother to write this check because you like taking shortcuts and you think you got it covered in your head. And so in reality, you're going to have a positive 5x and a negative 2x for a positive 3x, and that's going to be wrong because the middle term's not positive 3x, it's negative. So you should always, especially in the beginning, you should always be writing what the outers plus the inners add up to make sure you get that correct middle. So what's your answer? That binomial, those two binomials right there. If you do an attempt and you get the wrong middle, just cross it off and start again with your two parentheses. Put your front in there again and work on a second pair. All right, let's go to a second example. So example B, n squared minus 6n plus 8. First thing you got to have in your brain, by the way, the right-hand side are your thoughts, right? The right-hand side is what you're supposed to be thinking. So first thought should be factor out common factors first. Are there any? None, but you did check. You got to check. What's next? Somebody tell me what to do next. Ashton? Two parentheses. All right, that's next. That's step number 2, two parentheses. All right, somebody tell me, raise your hand, tell me what to do next. What is next? What's next? Everybody should be looking at your paper, figuring out what's next. What's next, John?
Factoring the...
Tell me what to put next. What do I put?
N in the front of both.
N in the front of both, because n times n is n squared. The n times the n gives us the front n squared. Now it's advisable on step 4 to write the possibilities. Now, after you get good, you can stop writing the possibilities. But it's good in the beginning to write the possibilities. I'll help you for time's sake. 8, you can have 1 times 8. But you could also have negative 1 times negative 8, right? You could have 2 times 4 or negative 2 times negative 4. Okay, so there's 4 pairs again. All right, I'm going to pause the video, see if you can find the correct factorization. All right, how many are sure they have the correct answer? Let me see your hands. Okay, so again, my brain, I'm going to show you my brain. So first thing I'm looking is, I always look at the outers first. Look, the whole time I'm doing this, please pay attention now. Please look up right now. The whole time, this is what I'm shooting for. If you're not aiming for a negative 6n, you don't know what you're doing. Picking my pairs right now is because I'm aiming for a negative 6n. So, I have an 8, I'm going for a negative 6. My brain, 4 and 2 is 6. Negative 4, negative 2. My outers are a negative 4x, my inners are a negative 4n, my inners are a negative 2n, for a grand total of negative 6n, cha-ching, and that's the factoring of it. Now, by the way, did anybody have n minus 4 times n minus 2? Anybody have the negative 4 in the front and the negative 2 in the back? Nobody? You could, though, right? Commutative property. So n minus 2 times n minus 4, or n minus 4 times n minus 2. How many got that correct? Okay. Questions? All right. Doctor can't help you if you're not telling them where the pain is. Let's do another one. All right. Why don't you guys do the first couple steps? Do the first 3 steps. Do the first 3 steps. I'm only going to give you a second, so. right, so stop where you're at, look up here. Just want to make sure, did you factor out the common 3? You better. I'm going to keep my color here. You better take out that common 3 first, otherwise you're in buku trouble. Factor out common factors first. There's a common 3 in each term. I took the 3 out of the 3x squared. I took the 3 out of the positive 9. I took the 3 out of the negative 30. Now, go ahead and finish it. By the way, don't forget about that 3. It's still there. Go ahead and finish it. Make sure you know what you're shooting for. If you don't know where you're aiming, you're not going to hit it. If you don't know where you're aiming, you're not going to hit it. Ileana, a few of the problems on your test had some factoring, and then it had some multiplying fractions where you had a factor to divide stuff out, or dividing fractions where you invert but factor to divide stuff out, and that's why the answer. So it might help you come Saturday. Did you find the right combo? Are you shooting for a positive 3 in the middle? Hey, 5 and 2 are 3 apart. If I put a 5 here, that's going to give me 5 of them. That leaves the 2 there. And I need the 5 to be positive with the 2 negative. A negative 2 and a negative 5 is a negative 10. It's a good pair. Again, my check. 5x on the outers, negative 2x on the inners. Sure enough, that's the positive 3x. 3 times the quantity x minus 2 times the quantity x plus 5, or 3 times the quantity x plus 5 times the quantity x minus 2. How many got that correct? Do you understand why you're wrong? Do you understand why your pairs don't work? Austin, do you have a question? You understand why your pairs don't work? You sure? Okay. You think so. Multiply your outers on your pair. Multiply your inners. You should have done that already anyhow. Does that give you a positive 3x in the middle? See, we're after this middle term, right? By the way, folks, don't forget to keep this 3 out in front, right? Whatever multiplier comes out is still a multiplier. Okay, one more until you get practice tonight. And boy, you got to get it figured out tonight. If you don't get it figured out tonight, then it's going to be a thorn in your side. What do you think? You think we got common factors in this one? Yeah, we do. Common 2. I'm going to try to keep my color here. Take the 2 out of the 2, that leaves you the a squared. Take a 2 out of a negative 12, leaves you a negative 6, because a negative 12 is a negative 2 times 6. And we still got AB. Take a 2 out of an 18, it's a 9 left, because an 18 is a 2 times 9. So you got 9b squared. We're just factoring out that common 2. All right. Now, see if you can finish it. Don't forget the b squared means that with your numbers will be a b each time. Like b times 9b, 3b times 3b, negative b times negative 9b, and negative 3b times negative 3b. Oops, screen. What are you after? A negative 6AB in the middle. That's what you're after. Make sure you know where you're aiming. Anybody find it yet? Keep looking for the right pairs. Keep looking for the right combination. It's all about the middle. It's all about the middle. It's all about the middle. Using a B and a 9B. A negative B and a negative 9B. Positive 3B and a positive 3B, or a negative 3B and a negative 3B. All the things that multiply to a 9B squared. All right, somebody raise your hand. Give me the back factors. Adam? How many agree with Adam, negative 3B, negative 3B? If you do the check on him, A times negative 3B is a negative 3AB. Negative 3B times an A is a negative 3AB for a grand total of negative 6AB. That is our middle. That is a correct factorization. And that is our answer in a means to an end. All right, factoring. Guys, your thoughts should be the column on the right. Do you have to show all that stuff? You better at least be thinking it. All right, and make sure you're checking those middles. That's the key, outers and inners.